Hello, and welcome to Sleepy Science. Tonight, we are not going to look upward at stars or outward across the surface of oceans. Tonight, we are going to slow down and wade gently into the quiet world of a creature that has been reshaping the land long before our cities existed. A creature that works through the night, that has engineered rivers, flooded meadows, and built entire worlds out of sticks and mud and water. Tonight, we explore the life of the beaver. Not the beaver of cartoons or simple nature documentaries, but the real animal, with all its strange biology, its ancient history, and its quiet but extraordinary power to transform the earth. There is something deeply soothing about the beaver's world. The slow movement of water, the soft sounds of a pond at dusk, the smell of fresh wood and cool mud. It is a world built not on urgency, but on patience, on the slow accumulation of effort, one branch at a time. So settle in now. Let your body become heavy and warm. Breathe in slowly and breathe out softly. If you enjoy these quiet journeys into science and the natural world, a like and a subscription helps carry Sleepy Science to other weary minds who need a gentle place to rest. But for now, all you need to do is listen and let the slow, steady world of the beaver carry you gently towards sleep. Beavers are the second largest rodents on Earth. When most people think of rodents, they picture small things, mice darting along baseboards or squirrels scurrying across branches. But the beaver belongs to an entirely different scale. A fully grown North American beaver can weigh anywhere from 16 to 35 kilograms. That is as heavy as a medium-sized dog. They can stretch to over a meter in length from the tip of their nose to the end of their broad, flat tail. Only the capybara, that barrel-shaped, gentle giant of South American riverbanks, outweighs them among the world's rodents. The beaver holds second place, and it holds that place with considerable dignity. There is something almost noble about a beaver. The way it sits upright to eat, holding food in its front paws like small hands. The way it surveys its pond with what can only be described as quiet satisfaction. And the sheer physical engineering of the animal is remarkable. Their hind feet are webbed, broad and powerful, built for swimming. Their front feet are smaller and dexterous, almost hand-like, used for gripping and carrying and placing. Their fur is dense and layered, an inner coat so fine and tightly packed that water never reaches the skin. And over that, longer guard hairs that repel water further still. A beaver can swim in near-freezing water and emerge without being truly wet beneath its outer coat. Their eyes are covered by a transparent membrane, a third eyelid called a nictitating membrane, which closes over the eye underwater like a pair of built-in goggles. Their nostrils and ears seal shut when they dive, their lips close behind their front teeth, allowing them to gnaw on wood even while submerged. Every part of the beaver is shaped for a life spent between land and water, between the surface and the deep, between the working and the resting. The beaver's tail is one of the most remarkable structures in the mammal world. It is flat, broad, and covered not with fur, but with a pattern of dark, leathery scales, something like a mosaic laid by a careful craftsman. It can measure over 30 centimeters long and nearly 15 centimeters wide. It is, in every sense, an extraordinary organ. The tail serves as a rudder while swimming, angled and adjusted with remarkable precision to steer through currents and around submerged obstacles. It acts as a prop on land, allowing the beaver to sit upright on its haunches while working, using the tail as a third point of contact with the ground, like a tripod. It is used for communication too, slapped hard against the surface of the water to produce a loud crack that carries a great distance and warns the colony of danger. And perhaps most surprisingly, the tail plays a role in temperature regulation. Because it is so well supplied with blood vessels close to the surface, the beaver can release excess body heat through its tail on warm days. In cooler weather, blood flow to the tail is reduced, conserving warmth. It is a biological radiator, adjustable by instinct, working quietly and constantly. Early European naturalists were so puzzled by the beaver's tail that they sometimes classified beavers as fish, at least for the purposes of religious dietary rules. Eating beaver on holy days of fasting was considered acceptable in some regions, because the tail was deemed fish-like. The beaver endured centuries of human confusion about its very nature, and through it all, it simply went on building. A beaver's teeth never stop growing. The front incisors of a beaver are large, curved, and impossibly strong. They are capable of felling trees that would challenge a human with an axe. But unlike the teeth of most mammals, a beaver's incisors do not stop growing at any point in the animal's life. They are continuously produced from the root, pushing forward as they wear away at the tip. This means the beaver must gnaw constantly, not just to collect building material or food, but simply to keep its teeth from growing too long. The color of those teeth is worth noting. They appear orange, not the pale cream of human teeth, but a rich, deep orange, almost amber. This color comes from iron compounds woven into the outer enamel. The iron makes the enamel harder and more resistant to chipping than the white inner layer of the tooth. So the front surface of the tooth, which is orange with iron-rich enamel, stays sharp, while the softer inner surface wears down more quickly. The result is a naturally self-sharpening chisel. As the beaver gnaws, the geometry of its own teeth ensures they stay sharp. No honing, no maintenance, just continuous use and continuous renewal. The beaver is, in a very real sense, its own tool shop, carrying with it the perfect cutting instrument wherever it goes, forever sharp, forever orange, forever growing. Beavers do not eat wood. This is perhaps one of the most common misunderstandings about beavers. When you watch a beaver gnaw through a tree trunk, it is easy to assume the wood itself is the goal. But beavers are not eating the wood they cut. The wood serves as building material, carried to the dam or lodge and woven into place. What beavers actually eat is the soft tissue beneath the bark. The cambium layer, a thin, sweet, moist sheath of living cells that carries nutrients up and down the tree. They eat bark, young twigs, and the tender growth of certain trees. Aspens and willows are among their favorites. These trees are not just food, but also building material, and they have the added advantage of regrowing readily from their stumps after being cut. A beaver can fell a willow, eat what it needs, use the rest for construction, and return years later to find the stump has sprouted again, ready to offer another season's worth of food and wood. In summer, beavers also graze on aquatic plants. Water lilies, pondweed, rushes. They swim slowly through their ponds in the long golden evenings, pulling stems up from the muddy bottom, eating with quiet thoroughness. There is something almost meditative about the way a beaver feeds. The deliberate pace, the unhurried attention to each mouthful, no urgency, no waste. Just the slow and careful taking of what the land and water freely offer. A beaver can hold its breath for up to 15 minutes. Under the still surface of a beaver pond, life is as active as it is above. Beavers swim through the submerged entrance to their lodge, carry branches from underwater caches to the dam, and inspect the foundations of their structures, all without surfacing for air. The beaver's physiology is beautifully adapted for this. When it dives, its heart rate drops dramatically, a response called the diving reflex, which slows oxygen consumption and routes blood preferentially to the brain and heart. Beavers can remain submerged for up to 15 minutes in optimal conditions. In winter, when the water is cold and their activity is slower, they may stay under even longer, moving through the dark beneath the ice with calm efficiency. They can navigate their submerged world almost entirely by touch and memory, knowing where each branch lies, where each tunnel leads, where the walls of the lodge give way to the dry sleeping chamber above. To imagine being inside a beaver's world underwater is to imagine a kind of suspended quiet, the muffled hush of water pressing in from all sides, the soft green-grey light filtering down through the frozen surface, the gentle resistance of water against fur, and somewhere in the darkness ahead, the rough edge of a branch waiting to be moved. The beaver moves through it all with the ease of an animal, completely at home, in its element. Beavers are among the few animals that fundamentally alter their own habitat. We call animals like this ecosystem engineers, and beavers are perhaps the finest example of this phenomenon in the entire animal kingdom, second only to humans in the sheer scale of the changes they create. When a beaver family moves into a stream, they do not simply adapt to what they find. They redesign it. They select a site where the stream is narrow enough to dam, where the banks are well forested with the kinds of trees they prefer, and where the land on either side is suitable for flooding into a broad, shallow pond. Then they begin, felling trees, cutting branches, dragging logs, packing mud, weaving sticks. Over days and weeks and months, a dam rises from the streambed. Water backs up behind it. The pond spreads outward into the surrounding land. Trees that once stood on dry ground now stand in water. Meadows that were once dry become wetlands. Streams that once ran fast and clear become slow and silted and still. And from all of this change, something extraordinary emerges. Not destruction, but abundance. The pond created by a beaver dam becomes one of the richest ecosystems in any temperate landscape. Insects thrive in the warm, shallow water. Frogs and salamanders breed in the muddy margins. Fish move in from connected waterways. Herons and kingfishers come to hunt. Ducks nest in the cattails. Otters arrive to play in the current over the dam. The biodiversity of a beaver pond can be many times greater than the simple stream that preceded it. And the beaver, sitting at the center of all this abundance, continues its work. Patient, unhurried, adding one more branch, one more handful of mud, one more repair to the ceaseless, quiet business of building the world it needs. Beaver dams can be enormous. The largest beaver dam ever discovered stretches for over 850 meters across a remote area of Wood Buffalo National Park in northern Canada. That is nearly a kilometer of interwoven wood and mud and stone, built entirely by beavers. It was first detected not by a ground survey, but by satellite imagery, visible from space. Scientists who studied the site estimated that the dam had likely been under construction for several decades, built and expanded and repaired by successive generations of beavers working on the same structure. The pond it created behind it was so vast that it had become an entire landscape, a network of channels and islands and quiet backwaters, extending for many hectares into the boreal forest. But even more modest beaver dams are marvels of instinctive engineering. A typical dam might be 5 to 10 meters wide and 2 meters tall. It is built with the downstream face angled gently, like a ramp, so that the weight of water presses into it and stabilizes it rather than washing it away. The upstream face is packed with mud and debris, creating a nearly watertight seal. Water is allowed to seep through slowly at the base, maintaining the pond level, without allowing the pressure to build to a point of failure. Beavers appear to monitor the water level of their ponds by sound. The sound of running water triggers them to investigate and repair. Silence, or the absence of flowing sound, tells them the dam is holding. If you play a recording of running water near a beaver dam, the beavers will investigate and begin trying to block the source of the sound, even if there is no actual breach. They are listening for the sound of need, responding to it with patient, tireless attention. The beaver lodge is a masterwork of insulation. While the dam holds the water in place, it is the lodge that holds the family safe. A beaver lodge is a mound of sticks and mud, often rising a meter or more above the surface of the pond. From the outside, it looks chaotic, a jumble of branches piled without apparent order. But inside, it is carefully structured. The base of the lodge is anchored to the bottom of the pond or built out from the bank. The walls are thick, packed with mud that freezes solid in winter, creating a barrier that predators cannot easily break through. At the very top, the beavers leave a small opening, not a door but a ventilation shaft, a tiny gap where air can circulate. This means that even in the depths of a northern winter, with the temperature outside plunging to -30 or colder, the inside of the lodge stays warm. The interior chamber sits above the waterline. It is dry, lined with shredded plant material and soft wood chips. A sleeping platform. The family curls together on this platform through the coldest nights, their combined body heat trapped by the mud walls and the snow that often piles up on top of the lodge for additional insulation. The entrances to the lodge are always underwater. A beaver ducks below the surface, swims through a short tunnel, and emerges into the dry interior. This design means that while the pond is frozen over, predators on the ice above cannot access the lodge at all. The wolves and coyotes and lynxes that might otherwise threaten the family stand helpless on the ice, looking down at the dark water, unable to reach what lies beneath. Inside the lodge, the beaver family breathes the warm, moist air and sleeps. Outside, the winter stretches wide and cold and quiet over the frozen pond. The snow falls, the ice deepens, and the beavers, invisible beneath it all, rest. Beavers are among the most devoted family animals in the wild. A beaver family, called a colony, is built around a monogamous breeding pair. Beavers mate for life. This is not merely a romantic notion, but a practical arrangement that serves the colony well. A pair that has worked together for years knows each other's habits and rhythms. They coordinate their building and their foraging. They share the work of the lodge with efficient familiarity. And they raise their young together, season after season, for as long as they both live. The young of the previous year, called yearlings, often stay with the family and help care for the new kits born in spring. So a typical lodge might contain the breeding pair, the new kits from this year, and the yearlings from last year, all living together in the warm interior. It is a multi-generational household, structured not by hierarchy, but by shared labor and shared warmth. At around 2 years old, the young beavers are gently but firmly encouraged to leave. They disperse along waterways, sometimes traveling many kilometers in search of a suitable place to settle. They are looking for a stream with good trees and manageable gradient, a place where they can begin the long work of creating their own pond, their own lodge, their own family. Some do not survive this journey. The dispersing beaver is vulnerable, alone, on unfamiliar territory. But those that find their place settle in and begin. They gnaw their first tree. They drag their first branch to the water. They pack their first handful of mud into the stream bed. And the ancient, patient work of building begins again. Beavers were once nearly driven to extinction. Through centuries of heavy trapping, North American beavers were reduced from an estimated population of perhaps 60 to 400 million animals to fewer than 100,000 by the early 1900s. The Eurasian beaver, a closely related species that once ranged from Britain to China, was reduced to just a handful of isolated populations, totaling perhaps 1,200 animals worldwide. The reason was their fur. Beaver pelts, particularly the dense underfur, were prized for making felt hats. For much of the 17th, 18th, and 19th centuries, the beaver felt hat was the most fashionable article of clothing a European gentleman could wear. The demand was insatiable. Beaver populations across Europe were exhausted within a century or two of the trade beginning. Then the search moved to North America. And there, the same story repeated itself with greater speed and greater scale. The entire economy of colonial North America was, for a long time, structured around the beaver pelt trade. Exploration of the continent was driven largely by the search for rivers with good beaver populations. Forts were built at trading points, Alliances between European powers and indigenous nations were formed and broken over access to beaver territory. Wars were fought, in part, over beavers. And through it all, the beavers diminished. River by river, valley by valley. The ponds they had built for millennia went quiet. The dams fell into disrepair. The wetlands dried. The waterfowl moved on. The fish disappeared from streams that became faster and shallower without the beavers' slow water management. The landscape lost something vast and vital, without fully understanding what it had lost. Conservation efforts in the 20th century brought both species back. In North America, legal protection and the decline in demand for felt hats, as silk became fashionable and then synthetic materials took over, allowed beaver populations to begin recovering. In Europe, careful reintroduction programs moved beavers from the last surviving populations in Norway, the Elbe River in Germany, and a few other refuges, back into rivers across the continent. Today, beavers have returned to many parts of Britain, France, Germany, Poland, and beyond. In some places, their return has been controversial, as farmers whose land borders rivers have found their fields flooded by beaver-dammed streams. In other places, their return has been celebrated, as rivers that had run straight and channelized and ecologically impoverished began to slow and widen and fill with life again. The story of the beaver's near extinction and slow return is a story about what happens when a single keystone species is removed from a landscape. And it is a story about recovery, about the resilience of nature and the willingness of a species to begin again, if only given the chance. Beavers play a significant role in filtering and cleaning water. The pond created by a beaver dam is not simply a body of still water. It is a slow, complex processing system for everything that flows into it. Water entering a beaver pond is slowed dramatically. As it slows, sediment it was carrying settles out. Particles of soil and organic matter that would otherwise travel downstream and cause turbidity drop to the bottom of the pond instead. Nutrients that might otherwise be lost downstream are captured in the pond ecosystem, feeding the aquatic plants, which are grazed by insects, which are eaten by fish, which support herons and kingfishers and otters. The cycle of nutrients becomes concentrated and productive in a way that a free-flowing stream simply cannot match. In regions where agriculture has led to high levels of nitrogen and phosphorus entering waterways, beaver ponds can act as natural buffers. Studies have shown that water flowing through a series of beaver ponds emerges significantly cleaner than when it entered. The pond traps excess nutrients, reduces erosion, and supports plant communities that stabilize the banks and filter the water further. This has led researchers and water managers in some countries to view beaver reintroduction, not only as a conservation goal, but as a practical water management strategy. A living, breathing, gnawing water treatment system, operating 24 hours a day, maintained by the animals themselves, requiring no electricity, no maintenance budget, no staff. Just beavers, working quietly in the dark. Beaver ponds can help mitigate drought and wildfire. In an era of changing climate and increasingly erratic rainfall, the beaver may be one of nature's most effective responses. A beaver dam does not simply create a pond. It creates a reservoir. Water that would otherwise drain rapidly downstream during wet periods is held back, stored in the pond and in the saturated soil around it. This stored water persists into dry seasons. In arid regions of the western United States, researchers have found that streams running through active beaver territories hold water many weeks longer into summer droughts than comparable streams without beavers. The saturated soils and the shade provided by the vegetation that grows around beaver ponds create cooler, moister microclimates. Plants grow more lushly. Willows and alders cluster along the banks, their roots drinking from the underground water the beaver pond has charged. And when wildfire sweeps through a landscape, beaver pond areas can act as refuges. The green, moist vegetation around the pond resists burning. Animals fleeing the fire can reach the water. The pond itself remains. Studies of wildfires in areas with active beaver populations have found that the burns often stop or slow at the margins of beaver-maintained wetlands, as if hitting a green wall of resistance built from water and willows and mud. In California, in Nevada, in Colorado, land managers are increasingly looking at beaver reintroduction, not as a purely ecological project, but as a tool for climate adaptation, a way of rebuilding the landscape's capacity to hold water, to resist drought, to buffer against the extremes that are becoming more frequent. And the beaver, unaware of all this strategy and policy and science, simply goes on doing what it has always done. Beavers were once far larger than they are today. In the Pleistocene epoch, the great stretch of geological time that encompassed the ice ages, a close relative of the modern beaver roamed the forests and wetlands of North America. It was called castoroids, and it was enormous. A fully grown castoroids would have been roughly the size of a black bear, perhaps 200 kilograms in weight, 2.5 meters in length, the largest rodent ever to live in North America. Its teeth were similarly scaled, large curved incisors that researchers have studied with fascination. Unlike its modern descendant, Castoroides may not have been a builder. The structure of its teeth suggests they may have been used for digging and processing aquatic vegetation, rather than felling trees. If so, the giant beaver was a grazer of wetlands rather than an engineer of streams. The architecture of the landscape, the building of dams and ponds, may be a more recent evolutionary specialization of the modern beaver lineage. Castoroids disappeared around 10,000 years ago, as the ice ages ended and the climate shifted. Its extinction coincided with the arrival of humans in North America and likely involved a combination of habitat change and hunting pressure. It vanished, along with the mammoths and mastodons and giant ground sloths that once shared its world. And in its place, the smaller, more adaptable, endlessly industrious modern beaver inherited the waterways. Beavers communicate in ways that go far beyond the tail slap. The loud crack of a beaver's tail on the surface of the water is perhaps the most dramatic form of beaver communication, but it is far from the only one. Beavers are also highly scent-oriented animals, and they maintain an elaborate system of chemical communication across their territory. They produce a substance called castoreum from paired castor sacs located near the base of their tail. Castoreum is a complex mixture of hundreds of chemical compounds, unique to each individual beaver in its specific chemical signature, yet carrying general information readable by all beavers. Beavers deposit castoreum on small mud mounds they build along the edges of their territory, often at strategic points near waterways and well-traveled paths. These scent mounds serve as signposts, as boundaries, as messages. A visiting beaver approaching another colony's territory will stop at these mounds, read the scent carefully with its sensitive nose, and interpret information about the colony that left it. Their sex, their reproductive status, how recently they were here, whether this territory is actively occupied or perhaps abandoned. Based on what it reads, the visiting beaver may decide to move on, or may leave a scent mark of its own, signaling its presence in return. Castoreum has also been used by humans for centuries. Indigenous peoples used it medicinally. Perfumers prized it for its warm, musky, vanilla-adjacent scent, which has a remarkable ability to fix other fragrances and make them last longer on skin. For a time in the early 20th century, castoreum appeared as a flavoring agent in certain foods, listed innocuously under the term natural flavor. It has since fallen largely out of use in food products, replaced by synthetic alternatives. But the perfume industry still sometimes uses it, the quiet chemical signature of a beaver's territory, drifting through the halls of high-end boutiques, as something rare and warm and old. Beavers are excellent swimmers but slow and vulnerable on land. In the water, a beaver is confident and capable. It can swim at speeds of up to 8 kilometers per hour. It can steer with precision, dive to significant depths, and carry substantial loads while swimming. It is completely at home in the element it has shaped its entire landscape to contain. On land, the beaver is a different creature entirely. Its hind legs are placed far back on its body, an adaptation for swimming that makes walking awkward and slow. A beaver on land moves with a waddling, rolling gait, dragging its heavy tail, pausing frequently to stand upright and survey its surroundings. It is not built for speed or agility on solid ground. A determined dog or a bold coyote can easily outrun a beaver in the open. This vulnerability on land is part of why beavers arrange their lives to minimize time spent there. They select trees close to the water, felling them so that they fall toward the pond rather than away from it. They excavate channels from the water's edge into the forest so that branches and logs can be floated rather than carried. They work most actively at night, when their nocturnal habits and the darkness offer some protection from daytime predators. Their hearing is excellent, their sense of smell is sharp, and they are intensely attentive to anything unusual in their environment. A strange sound on the bank, an unfamiliar scent on the breeze, and the beaver is gone, slipping back into the water with barely a ripple, diving beneath the surface, out of reach, invisible, safe. Beaver canals can extend for hundreds of meters. The beaver's solution to the problem of distance from water is remarkable in its simplicity and effectiveness. When a beaver wants to harvest trees that are further from the pond's edge, it does not simply make longer and more dangerous trips over dry ground. It extends the pond. Or rather, it digs canals. Starting at the water's edge, Beavers excavate narrow channels into the surrounding land, using their front feet to scoop mud, and their strong bodies to push material aside. The canal fills with water from the pond behind it. As it deepens and lengthens, it becomes navigable. The beaver can now swim deep into the forest along its own handmade waterway, fell a tree right at the canal's edge, and float the branches back to the lodge without ever setting foot on open ground. Beaver canals can reach lengths of several hundred meters. Some systems of canals, built and maintained over many years by successive generations, create entire networks connecting the main pond to foraging areas, to satellite ponds, to secondary dams further upstream. From the air, an active beaver territory can look almost like a small town's waterway system, a maze of channels and ponds and dams, built from nothing but instinct and effort, and time. Beavers are careful to store food underwater for winter. In the temperate and subarctic regions where beavers live, winter presents an obvious challenge. The pond freezes. The trees are bare. The ground is locked under snow. But a beaver family in a well-maintained lodge does not starve. They plan ahead. In the weeks before the first freeze, beavers enter a period of intense foraging and preparation. They cut far more branches than they can eat immediately, carrying them to the pond and pushing them into the muddy bottom near the lodge entrance. This underwater cache, sometimes called a food pile or winter cache, can be enormous. A large family may assemble a pile of branches several meters across and as tall as a human. When the ice forms over the pond, the beavers are sealed in, but they can swim out from the lodge through their underwater tunnels, reach the food pile, pull a branch free from the mud, and carry it back to the dry chamber to eat. The cold water preserves the bark and the inner cambium through the winter months, keeping it fresh and nutritious long after the trees above ground have shut down. The caching behavior of beavers is not learned. Young beavers begin participating in food pile construction before their first winter, driven by what appears to be a deep, instinctive response to shortening days and cooling temperatures. The urgency of autumn preparation is written into their biology, just as the rhythm of the day and the length of the light tells them when to begin, and when enough has been stored. Baby beavers, called kits, are remarkably precocious. Beaver kits are born in spring, typically in a litter of 2 to 4, though litters of up to 6 have been recorded. They arrive into the world already furred, their eyes open, their teeth present. Within hours of birth, they are mobile enough to move around the lodge chamber. Within days, they are capable of swimming. They are not particularly graceful at first. The buoyancy of a newborn kit is so high that they tend to bob at the surface rather than diving easily. The parents are attentive and gentle. Both the mother and father care for the kits, grooming them, carrying them, nudging them back into the lodge if they stray too far. The yearlings from the previous year also participate in kit care, showing a level of cooperative parenting unusual among rodents. The lodge is full of life in spring, warm with bodies and active with the small, squeaking presence of new kits exploring their world. By summer, the kits are swimming confidently and beginning to assist in small ways with the family's work. They chew on sticks, carry small branches, explore the canal system. They are practicing, learning the work of being a beaver not through instruction, but through play and imitation and the simple, irresistible pull of instinct. By autumn, they are genuine contributors to the food cache preparation, adding their small branches to the pile that will sustain them all through the long winter ahead. The sound of a beaver pond at night is one of nature's most peaceful compositions. Close your eyes for a moment and let yourself drift toward the edge of a beaver pond. The light is fading, the sky deepening from amber to gray to a deep, quiet blue. The first stars appear, faint and uncertain. The air is cool and carries the smell of water and wet wood and the sweetness of willow bark. From across the pond, there is the soft sound of ripples spreading from a beaver's movement. A V-shaped wake trails behind a dark shape moving slowly through the water. The beaver is heading toward the far bank where a stand of young aspens waits. You can hear, if you listen carefully, the quiet sound of it pulling itself onto the bank. A brief pause. Then, the methodical, rhythmic gnawing. Steady and unhurried. A sound like a slow, patient drum. Frogs begin calling from the shallows. One voice, then three, then a chorus that fills the hollow over the water. Somewhere in the reeds, a duck settles for the night with a quiet, contented murmur. An owl calls once from the far trees. The gnawing continues, steady and sure. The stars multiply in the pond's surface, reflected and rippling gently each time the beaver moves. There is a crack, a soft and woody sound, and then a long, trailing rustle as a young tree leans and falls. A splash as its upper branches touch the water, and then the sound of the beaver working again, cutting branches, moving wood, beginning the patient transport of material that will occupy it for hours yet. All around it, the pond breathes. The frogs sing. The stars drift overhead. And the world is very quiet and very old and very good. Beavers have a second, specialized claw for grooming their fur. Look carefully at a beaver's hind feet, and you will notice something unusual. On the second toe of each hind foot, there is a split claw, a doubled nail that appears almost like a small comb. This is called a preening claw or grooming claw, and it is exactly what it sounds like. The beaver uses this split claw to comb through its fur, working out tangles and debris, maintaining the dense, layered structure that keeps it waterproof. Fur maintenance is critically important for an animal that spends much of its life in water. A beaver whose fur loses its waterproofing would rapidly become hypothermic in cold water, its insulation compromised, its body heat draining away with every dive. The grooming claw is not a luxury. It is a survival tool. Along with the special oil glands near the base of the tail that beavers use to waterproof their fur, the grooming claw is part of the careful, daily maintenance that keeps the animal seaworthy, or rather, pond-worthy. Watching a beaver groom itself is an unexpectedly charming sight. It sits on a log or a bank in the late afternoon light, working methodically through its coat with the split claw, reaching over its shoulders and down its sides with an ease that belies its stocky build. It oils its fur by rubbing the oil from its glands along its flanks. It turns its broad tail this way and that, inspecting it. It combs its belly fur with careful attention. And when it is done, it slides back into the water and vanishes. Beavers have influenced the entire hydrology of North America. Before European colonization and the collapse of beaver populations, researchers estimate that there were perhaps 60 million or more beavers in North America. At that density, beavers would have dammed virtually every suitable stream across the continent. The cumulative effect of their engineering on the landscape would have been extraordinary. Rivers that today run fast and straight through channelized courses would once have moved through sequences of beaver ponds, slowing and spreading, depositing sediment, charging the surrounding groundwater. The great valley floors of North America, the broad meadows along rivers like the Missouri and the Sacramento and the Platte, would have been shaped significantly by the accumulated work of millions of beaver dams over thousands of years. Some researchers have estimated that the deep, rich soils of valley meadows across the American West, soils that have been farmed and grazed for centuries, were in large part created by the slow accumulation of sediment in beaver ponds. The fertile land that attracted farmers was built, layer by layer, by the sediment-trapping function of the beavers' dams. The farms that replaced the beavers were standing on the beavers' own work. Beavers may have been a factor in shaping the routes of ancient human migration. This is a more speculative territory, but some researchers have proposed that the vast network of beaver-maintained wetlands in pre-colonial North America would have significantly influenced how early human populations moved through the landscape. In a world without roads or bridges, water was both obstacle and highway. Rivers were crossed at fords, and fords were most easily found where streams were broad and shallow. Beaver-dammed streams backed up into broad, shallow ponds would have been easier to ford than fast-running channels. The beaver ponds would also have provided reliable sources of food, water, and shelter material for human travelers. The paths that people walked through the landscape may have been shaped in part by the locations of beaver ponds, routes threading through the network of wetlands that the beavers built and maintained. Indigenous peoples across North America certainly knew the beaver intimately. It figured in the cosmologies, the stories, and the practical knowledge of dozens of cultures. The beaver was hunted for food and fur, but also respected for its industry and its intelligence. In some traditions, the beaver was seen as a kind of teacher of good work habits, of patience and preparation, of building well and building to last. Eurasian beavers are a separate species with their own fascinating story. The animal we have been talking about is largely the North American beaver, Castor canadensis, but its close relative, the Eurasian beaver, Castorfiber, shares the same genus and much of the same biology, while being a genetically distinct species. The two species cannot interbreed. They have different numbers of chromosomes, and there are subtle differences in their skull shape, their castor-sac anatomy, and aspects of their behavior. The Eurasian beaver was once found across the entire expanse of the continent, from the British Isles to the Pacific coast of Siberia. By the early 20th century, it had been hunted nearly to extinction, with perhaps 8 surviving populations totaling around 1,200 individuals. The largest surviving population was in Norway, where a tiny remnant had clung on in remote valleys. Others survived on the Elbe River in Germany, in the Rhone Delta in France, and in a few other isolated refuges. From these remnants, conservation efforts beginning in the mid-20th century began moving beavers to new locations. Beavers were reintroduced to Sweden, Finland, Russia, Poland, the Netherlands, and eventually to Britain, where the last native beavers had been hunted out several centuries earlier. The response of rivers and wetlands to the return of Eurasian beavers has been closely studied and largely celebrated by ecologists. The same story that unfolded in North America is unfolding again in Europe. Streams slowing, ponds forming, wetlands returning, species coming back. In Scotland, beavers that were reintroduced to the River Tay in the early 2000s have established themselves across a significant stretch of river. In Devon, a trial reintroduction to the River Otter has been followed with such enthusiasm that it has become a permanent part of the river's ecology. Farmers who initially objected to the flooding have, in some cases, come to appreciate the beaver ponds as drought reserves and as features that attract visitors and attention. The story is still unfolding, complicated and nuanced and alive, like all the best stories. The beaver's engineering skills appear to be partly innate and partly learned. One of the most interesting questions in beaver biology is how much of their building behavior is programmed into them from birth, and how much is learned from watching and doing. The answer appears to be both, in different proportions for different aspects of the work. The basic impulse to dam running water, to build a lodge, to stockpile food, these appear to be deeply instinctive. Beavers raised in captivity, without parents or older role models, will attempt to build dams and lodges, using whatever material is available, even inappropriate materials like plastic pipes and cardboard tubes. The urge is there. The general architecture is there. But the finer points, the selection of the best dam site, the most effective way to pack mud, the optimal length and branching of canals, these seem to improve with experience and observation. Young beavers that grow up in a well-established, complex colony seem to learn from the older animals around them. They watch, they imitate, they practice, and over the years, they develop a fluency in the work that goes beyond mere instinct. A beaver that has spent 5 years maintaining a complex pond system operates with a kind of expertise, a knowledge of local conditions and effective techniques that is genuinely impressive. Researchers who study individual beavers over multiple years have noted that experienced animals make different choices than young ones. They select better dam sites. They build more efficiently. They respond more quickly to breaches. They are, in the truest sense, getting better at their work as the seasons pass. Beavers can dramatically change the carbon stored in a landscape. In the complex accounting of carbon that scientists now track with such urgency, beavers turn out to be a surprisingly significant factor. When beavers dam a stream and flood surrounding land, dead trees killed by the rising water begin a slow process of decay. But waterlogged conditions are low in oxygen, and low oxygen environments slow decomposition dramatically. Material that might rot away quickly on dry land persists for decades or centuries in saturated soil. Over time, the accumulated organic matter in the sediment of a beaver pond can become a significant carbon store. Studies of old beaver pond sites, what ecologists call meadows, which are the rich, flat-bottomed valleys left when beaver ponds eventually drain or are abandoned, have found extraordinarily high carbon content in their soils. Beaver meadow soils can contain 2 to 3 times more carbon than surrounding upland soils. They are, in effect, buried carbon reserves, created over centuries by the accumulated decay of organic matter, in the low oxygen embrace of the beaver pond. As researchers explore nature-based solutions to climate change, the beaver's role in carbon sequestration has attracted serious scientific attention. A landscape populated with beavers, with its ponds and wetlands and organic-rich soils, stores more carbon than the same landscape without them. The beaver is, without any intention or awareness, a carbon farmer, burying the past in the soft, dark sediment of its ponds, one season at a time. The relationship between beavers and fish is complicated and fascinating. In popular imagination, beaver dams are sometimes portrayed as barriers harmful to fish, blocking the upstream migration of salmon and trout. And in some cases, particularly in rivers with compromised fish populations and altered hydrology, this can be a genuine concern. But the relationship between beavers and fish is far more complex than simple obstruction. For many species of fish, beaver ponds provide crucial habitat. The warm, still water of a beaver pond is ideal for young fish, offering shelter from predators and abundant invertebrate food. Juvenile salmon, trout, and many other species grow rapidly in beaver ponds, before moving on to faster water as adults. Studies in streams with and without beavers have found significantly higher fish populations in beaver-modified stretches across a wide range of species. In late summer, when streams without beavers may shrink to thin, warm trickles that stress or kill fish, beaver-dammed streams maintain deeper, cooler pools. These refuges allow fish populations to survive dry spells that would otherwise cause significant die-offs. And in rivers with naturally good migration routes, salmon have been observed finding ways past beaver dams, either jumping them at low points or swimming through gaps in the structure. The relationship, like most things in ecology, is less about simple harm or simple benefit than about context and complexity and balance. Beavers sleep in cycles that roughly follow the rotation of the Earth, but not exactly. Beavers do not keep human hours. They are primarily nocturnal and crepuscular, most active in the hours around dawn and dusk and through the night. But their internal clocks do not run on a strict 24-hour cycle. Research on beavers in captivity, and through the careful observation of wild animals, has revealed that beavers have an internal rhythm of approximately 29 hours, longer than the human circadian cycle. In the wild, their activity is entrained by environmental cues, by light and darkness and temperature. But in the constant conditions of a northern winter, when the beavers may spend weeks or months inside the lodge or beneath the ice with little exposure to changing light, their activity patterns drift. They cycle through periods of active work and deep sleep according to their longer internal clock, gradually shifting out of phase with the human day, out of phase with the surface world, keeping their own quiet time, in the dark beneath the ice. This is one of the most evocative things about beavers in winter. While the world above is locked in frost and short days, while humans set their alarm clocks and follow their rigid schedules, the beavers in their lodge below the ice are drifting through a longer, slower rhythm, sleeping, waking, eating, sleeping again, following the ancient clock inside them, unconcerned with hours or minutes or the demands of the world above. Just the slow, warm, dark turning of their own time. Beavers played an unexpected role in the history of cartography. The search for beaver pelts drove European explorers deeper into the North American continent than almost any other incentive. Rivers that had never been mapped by European cartographers were traced by trappers following beaver populations. The Missouri, the Columbia, the Snake, the Green, the Platte, and dozens of smaller waterways were first documented in European records by men following beavers upstream. The Hudson's Bay Company, founded in 1670, was essentially a beaver pelt trading enterprise. Its trading posts became the seeds of settlements. Its routes through the wilderness became roads. Its knowledge of river systems became the foundation of the maps that would eventually show the entire continent. The geography of Canada, in a very real sense, was first sketched out by Europeans following the distribution of beavers. The beaver appears on the Canadian coat of arms, on the Canadian nickel, on the logo of the Hudson's Bay Company, and in dozens of other national symbols. It is the official animal of Canada. This is not sentiment. It is history. The country's geography, its early economy, its colonial development, all of it shaped profoundly by this quiet, thick-furred, orange-toothed animal, living its patient life in streams across the boreal forest. The beaver has a sophisticated relationship with the concept of patience. There is something philosophically satisfying about the beaver as a symbol, not because it is dramatic or impressive in the way of a lion or an eagle, but because of the quality of its effort. The beaver does not hurry. It does not panic. It does not attempt great single acts of heroism. It does one small thing at a time, repeatedly, consistently, without stopping. A beaver building a dam does not see the finished dam and work backward. It responds to the immediate. Water running where it should not, fix it. A branch needed here, place it. Mud needed there, pack it. The dam emerges not from a plan, but from the accumulated response to 1,000 small necessities, each addressed in turn until the whole is complete. And yet the whole is complete. The dam holds. The pond fills. The lodge stands. And the family sleeps inside it, warm and safe and fed, through the longest and coldest night of the year. There is a kind of wisdom in that. Not a wisdom that can be explained or planned, but a wisdom that is lived, one branch at a time, one season at a time, for as long as the stream runs and the trees stand at its banks. Beavers are sensitive to the acoustic properties of their environment. We mentioned earlier that beavers respond to the sound of running water and are triggered to repair when they hear it. But their acoustic sensitivity goes further than this. Beavers seem to recognize the particular acoustic signature of their own territory, its echoes, its rhythms, its characteristic sounds. Researchers who have worked with beavers note that the animals respond differently to recordings of water from their own pond versus water from an unfamiliar location. Their own pond is familiar, known. Its sounds are not a trigger for alarm. Beavers also produce vocalizations that are rarely heard by humans. Inside the lodge, family members communicate with soft murmurs, low hisses, and gentle whines. Young kits are particularly vocal, producing high, thin squeaks that prompt immediate responses from parents. These sounds are intimate, private. They belong to the interior of the lodge, to the warm darkness where the family lives its hidden life, beyond the reach of the ice and the cold and the watching world above. To know that beavers speak to each other, in the warmth of their mud-walled homes, in voices too soft for us to usually hear, is to feel something tender toward them. Something like recognition. The small sounds of family, the murmur of companionship, the language of warmth and closeness, and being known. The wetlands created by beavers support threatened species around the world. Wherever beavers create ponds and wetlands, a cascade of ecological benefits follows, many of which extend to species that have become rare or threatened in heavily modified landscapes. In Britain, the return of beavers to rivers in Devon and Scotland has been accompanied by increases in water vole populations, one of Britain's most rapidly declining mammals. Water voles need slow, deep water with vegetated banks, exactly what a beaver pond provides. In North America, beaver ponds have been linked to the recovery of river otters, which declined severely following the near extinction of beavers. Moose favor beaver ponds for the aquatic plants that grow in them, wading into the shallows to reach the nutritious underwater vegetation. Wood ducks nest in the cavities of trees killed by beaver flooding. Great blue herons stand like gray statues in the shallows, waiting with their extraordinary stillness for fish to come within reach. In Europe, the reintroduction of Eurasian beavers has benefited populations of rare wetland birds, amphibians, and aquatic invertebrates. Rare plants that require specific waterlogged conditions have recolonized areas adjacent to beaver ponds. The European pond tortoise, one of the continent's rarest reptiles, has been found using beaver-created wetlands in areas where it had long been absent. Each pond a beaver builds is not simply water and mud. It is a promise of habitat, an invitation extended across the landscape. To every creature that needs slow water and shelter and the particular richness that only a wetland can provide. The beaver builds for itself, but the world it builds belongs to everyone. Beavers have been used as a symbol of industry across many centuries. The beaver's reputation for hard, methodical work has made it an enduring symbol of industry and diligence. Beyond Canada, the beaver appears in the logos of universities, in city coats of arms, and in corporate emblems across North America and Europe. The Massachusetts Institute of Technology chose the beaver as its mascot, on the grounds that the beaver is nature's engineer, building complex structures through applied knowledge and persistent effort. The American city of Portland, Oregon, is sometimes called Beaverton for its historical beaver trade. The city of New York has a beaver on its official seal, honoring the pelt trade that gave the Dutch colony of New Amsterdam much of its early wealth. In countless ways, the image of the beaver is woven into the institutional fabric of the societies that once consumed them so voraciously, and now, slowly, are learning to welcome them back. There is an irony in that. The animal whose fur was taken to adorn the heads of fashionable Europeans now adorns the logos of their most prestigious institutions. The beaver went from quarry to symbol, from near extinction to emblem, and through it all continued doing exactly what it had always done: building, maintaining, working through the night, in the cold water, unaware of the meaning we attach to it, entirely absorbed in the simple and ancient business of making a home. The relationship between the beaver and the willow is one of ecology's most elegant partnerships. If the beaver has a favorite tree, it is probably the willow. And the willow, in return, seems almost made for the beaver. Willows grow abundantly along waterways. They are among the fastest growing trees in temperate climates, producing new shoots with remarkable speed. When a beaver cuts a willow, even down to the stump typically sprouts again within weeks, sending up multiple new shoots that will become harvestable branches within a year or two. This means that a beaver does not necessarily deplete its food supply by eating willows. It may actually encourage more willow growth. The coppicing effect, the response of the willow to being cut, produces a more densely branched shrub than an uncut tree would become. The beaver, by feeding on the willow, creates conditions that produce more willow. The willow, by regrowing after cutting, provides a renewable food supply for the beaver. And willows, of course, are themselves great stabilizers of stream banks. Their roots grip the soil and hold it. Their shade keeps the water cool. Their fallen branches provide habitat for invertebrates. Their leaves, dropping into the water in autumn, feed the stream ecosystem through winter. Beaver and willow, builder and tree, ancient companions beside every stream, each serving the other, each shaped by the presence of the other, since long before any human walked the land between them. A beaver pond is one of the most complex ecosystems a stream can become. We have spoken of the biodiversity that follows a beaver dam, but let us dwell in that complexity for a moment. Let us float quietly across the surface of a beaver pond on a warm summer evening and take account of what we find. At the water's edge, where the mud is soft and the vegetation thick, frogs sit on every available surface. Green frogs, bullfrogs, leopard frogs. Their calls overlap and weave together into something that feels almost musical. In the shallows, dragonfly nymphs hunt through the tangle of submerged stems. Above the surface, the adult dragonflies patrol in flickers of color. Blue and green and copper, hovering, darting, suspended in air with a precision that seems impossible. Beneath the surface, the water is alive with invertebrates. Caddisfly larvae in their tiny stick cases, mayfly nymphs clinging to stones, water beetles rowing through the green-lit water with their oar-like legs. Small fish, sunfish and perch and young trout, hanging in the water column or pressing close to the tangled root masses along the bank. Above the surface, swallows cut low arcs over the water, scooping insects from the air. A kingfisher, electric blue and startling, perches on a dead branch above the pond's margin, motionless for long minutes before dropping like a thrown stone into the water. It emerges, a small silver fish gripped crossways in its beak, and vanishes upstream. And at the center of all of this abundance, barely visible, the dark shape of a beaver's back moving through the water, a ripple spreading from its passage, a wake that rocks the surface lilies gently. The engineer at work, moving through the world it made, belonging to it entirely, the heart of an ecosystem that would not exist without it. Beavers have inspired human engineering and architecture. The beaver was doing what engineers now call biomimicry, long before humans were building anything at all. And in more recent centuries, human engineers have occasionally looked at beaver dams for inspiration. The basic principle of the beaver dam, a permeable structure that slows water without completely stopping it, allowing controlled seepage while maintaining a stable reservoir level, is actually quite sophisticated. Traditional indigenous fish traps in North America sometimes used similar principles, weaving structures of sticks that allowed water to pass, while retaining fish. Early mill dams in Europe were built on similar foundations, creating mill ponds through partial damming of streams. And modern leaky dam structures, built from natural materials in upland streams to slow water flow and reduce flooding downstream, are in many ways inspired by or functionally equivalent to beaver dams. In Britain, conservation groups and river managers are now deliberately building leaky dams out of logs and brushwood, in streams where beavers have not yet returned. The goal is to create some of the hydrological benefits of beaver activity, while waiting for the real thing. They call these structures beaver dams analogs, and the name says everything. We are building imitations of something that an animal figured out millions of years before us. Let us imagine ourselves, now, on the edge of sleep, standing at the margin of a beaver pond in the deep hours of the night. The sky above is a dense, cold blue, scattered with stars. The air is still. The only sound is the faint, rhythmic sound of water flowing slowly over a low point of the dam somewhere behind us. And far across the pond, the soft, continuous sound of gnawing. The beaver is working, as it will all night, as it did last night, as it will tomorrow. There is no urgency in the sound, no hurry, just the patient, steady rhythm of an animal doing the thing it is made to do, in the dark, in the cold, beside the water, one branch at a time. The stars move overhead so slowly that the motion is impossible to perceive. The pond breathes. The frogs have gone quiet. A mist is rising from the surface of the water, thin and white, curling in shapes that have no name and then dissolving. Inside the lodge, barely visible as a dark shape at the center of the pond, the kits are sleeping, curled together, warm, breathing in slow, even rhythms. The beaver that is working will return to them before dawn. It will slide through the cold water, dive beneath the surface, pull itself up through the underwater tunnel, and emerge into the dry chamber. It will curl beside the kits, its body warm and heavy, its work done for the night. And the pond will be still around the lodge, the mist rising and dissolving, the stars slowly turning, the water lapping very quietly. At the dam, beavers have been documented felling trees with impressive precision. The skill with which a beaver fells a tree is one of the most striking things to observe about these animals. Working with nothing but their own teeth, beavers cut through trunks that would challenge a significant piece of human machinery. A large beaver can fell an aspen with a trunk 20 centimeters in diameter in under 15 minutes. It works in a characteristic way, making angled cuts that together create the hourglass-shaped stump that is the most reliable sign of beaver activity in any woodland. The angle of the cuts determines which way the tree falls, and experienced beavers appear to work with an awareness of the direction of fall. Trees that stand close to the water are generally felled toward the pond, minimizing the drag required to move them. Trees in denser woodland may be felled into natural openings between other trees. The beaver does not, of course, plan this in the human sense, but experience and the subtle feedback of the way a tree responds to each cut combine to produce results that can look remarkably deliberate. The largest tree ever recorded as being felled by a beaver had a trunk diameter of over 100 centimeters, a genuinely massive forest tree. Whether the beaver successfully processed and used such a tree, or whether it represented an overly ambitious undertaking, the record speaks to the capacity of the animal's teeth and the persistence of its effort. The beaver does not look at a large tree and hesitate. It simply begins. Beavers were once believed to have medicinal properties. In medieval and early modern Europe, the beaver was the subject of extraordinary and creative medical lore. Castoreum, the secretion from the beaver's castor glands, was believed to be a universal medicine. It was prescribed by physicians for everything from headaches and epilepsy to toothaches and fever. It was used as a topical treatment for skin conditions. It was administered in tinctures and powders and pills. The great physician Hippocrates may have written about it, and it appears in the medical literature of many ancient cultures. Interestingly, modern analysis of castoreum has found that it does contain salicylates, compounds related to aspirin, derived from the willow bark that beavers eat. So castoreum collected from beavers that had been eating willow would actually have had mild anti-inflammatory and pain-relieving properties. Not a universal cure, but not entirely useless either. The medieval physicians, working without chemistry or clinical trials, had noticed something real. The beaver, by eating willow, had carried the willow's medicine inside it, and humanity, in its particular way, had found a use for that too. Beavers perceive their world differently from humans in several important ways. The beaver's sensory world is shaped by the demands of a life spent between land and water, active at night, working with materials gathered by touch and smell as much as sight. Their eyes are positioned on the sides of their head, giving them a wide field of view that is valuable for detecting movement, particularly the approach of a predator, rather than the precise depth perception that forward-facing eyes provide. Their color vision is limited compared to humans, but their sensitivity to ultraviolet light is greater than ours. Under certain conditions, they may perceive patterns and markings in their environment that are entirely invisible to the human eye. Their sense of smell is exceptionally well developed. It is their primary tool for reading the social landscape, for understanding who has passed this way, how recently, and in what state of health or readiness. Their touch is sensitive and important. The beaver's lips, capable of closing behind the incisors while gnawing, are richly supplied with sensory cells. They can feel the texture of wood, distinguish between different species by touch and taste, assess whether a branch is suitable for eating or building while still processing it. The hands, or rather the front feet, are similarly sensitive, capable of manipulating materials with a dexterity that surprises those who see it for the first time. The beaver lives in a world that we can only partially imagine. A world of scent maps and chemical signals, of the feel of wood against its lips, of the sound of water and what it means, of the dark warmth of the lodge and the cold silver of the water below the ice. A world at once utterly foreign to us, and, in its rhythms of work and rest and family, not entirely unfamiliar. Beavers are far more socially nuanced than they are usually given credit for. The popular image of the beaver is of an industrious but essentially simple animal, a kind of biological machine for building dams. But research into beaver social behavior tells a more complex story. Within a family group, individuals have distinct personalities and roles. Some individuals are bolder and more likely to investigate novelty. Others are more cautious. Some are more active in dam maintenance. Others focus more on foraging. The pair bond between the mated adults shows signs of genuine coordination and mutual responsiveness. Pairs have been observed engaging in what researchers describe as social grooming, sitting together and working through each other's fur. This behavior, common in many social mammals, functions both to maintain fur condition and to reinforce social bonds. Beavers that have been paired for many years move through their pond together with a coordination that is easy to read as familiarity. Each knowing the other's likely moves, each trusting the other's judgment. When one member of a long-established pair is removed or dies, the remaining animal shows clear signs of disruption. Changes in activity pattern, increased anxiety behaviors, reduced dam maintenance in the initial period. The loss of a partner leaves a gap in the functioning of the colony that takes time to fill. Grief is a strong word to use for an animal, but disruption following loss is real and measurable, and that at least suggests that the bonds beavers form are more than merely functional. The fossil record of beavers stretches back over 30 million years. The family Castoridae, to which modern beavers belong, is an ancient one. Fossils attributable to early castorid rodents have been found in rocks dating to around 33 to 34 million years ago in the Eocene epoch. Over the tens of millions of years that followed, the castorids diversified into many forms, some quite unlike the modern beaver. Some early relatives were burrowers, not builders, creating elaborate spiral burrows in dry ground. Others lived in swampy environments and appear to have been predominantly aquatic. The genus Castor itself, the direct ancestors of modern beavers, appears in the fossil record around 7 million years ago, in the Miocene, and from there the lineage extends in an unbroken line to the animal working beside a pond today. 7 million years of beavers. 7 million years of dams and lodges and food caches. 7 million years of orange teeth gnawing through wood in the dark. The beaver has outlasted the mammoths that once walked beside it. It has outlasted the giant cave bears and the saber-toothed cats and the enormous ground sloths. It has survived ice ages and warm periods and the arrival of our own species. And through all of that, it has kept building. The same solution to the same problem. Water is easier to live beside if you control it. A dam here, a pond there, a lodge in the middle, a family inside. Simple, ancient, astonishingly effective. Still going. Beavers contribute to the water cycle in ways that affect entire river systems. We have spoken of how beaver ponds store water and release it slowly. But the reach of this effect extends far beyond the immediate vicinity of any single pond. A river system with active beaver populations throughout its watershed behaves fundamentally differently from one without. The hydrograph of the river, the pattern of how its flow rises and falls through the seasons, is smoothed and moderated. Peak flows during heavy rain events are reduced because water is held back in beaver ponds across the watershed before it reaches the main river. This reduces the risk of flooding in the valleys downstream, and the water that is held back is released slowly through the dry months that follow, maintaining river flows at times when rivers without beavers would shrink. The river breathes more evenly, more steadily, more reliably, because something is holding its breath upstream. In parts of Europe and North America, where flooding has become more frequent and more severe, and where drought in summer has become a growing concern, the beaver's role as a watershed regulator has begun to be taken seriously by government bodies and water managers. Funding programs to encourage the return of beavers are now active in several countries. The living, working, gnawing infrastructure of the watershed is being reinstated after centuries of absence. And the rivers, slowly, are beginning to breathe more easily. The sounds of building. There is a sound that belongs only to the hours after dark. In the places where beavers work, it is the sound of wood being cut, not the sharp crack of an axe, but something quieter and more rhythmic. A soft, regular gnawing, a sound with a patience built into its very tempo. It says, without words, that the work continues, that there is no hurry, that what needs to be done will be done. And beneath that sound, if you are very still and listening very carefully, there is the sound of water, the steady, low music of the pond, water moving slowly over stone, water lapping at wood, water breathing in the dark. These are the sounds that have accompanied the night in the wetlands of the northern world, for longer than our species has been here to hear them. There is something deeply comforting in that, in knowing that these sounds were going on before us, and will go on, given care and time, long after us. The beaver gnawing in the dark, the pond breathing, the family sleeping in the warm interior of the lodge. Ancient, continuous, unhurried, as steady as the turning of the seasons, and the slow filling of ponds, and the patient work of building a world, one branch at a time. Beavers alter the very chemistry of the water around them. A beaver pond is not merely a physical structure. It is also a chemical environment, shaped and maintained by the biology of everything living in and around it. The water chemistry of a beaver pond differs substantially from that of the stream that feeds it. The slowing of water allows dissolved oxygen levels to stratify, with warmer surface water holding less oxygen, and the cooler, darker bottom water holding different chemical conditions entirely. Anaerobic bacteria thrive in the oxygen-poor sediment at the bottom of the pond, breaking down organic matter in ways that produce methane and other compounds. This is part of why old beaver pond sediments are so rich in partially decomposed organic material. The conditions for decomposition are slowed. But it also means that beaver ponds are sites of methane production, a greenhouse gas. The relationship between beavers and climate is therefore genuinely complex. They store carbon? Yes. But they also produce methane in their ponds. Researchers continue to study the balance between these effects, trying to understand the full accounting of the beaver's role in the carbon cycle. What is clear is that the beaver pond is not a passive body of water. It is a reactor, a chemistry set, a living system in which the interaction of water, sediment, organic matter, bacteria, plants, and animals creates conditions that no engineer would design from scratch, but which turn out to be extraordinarily productive and valuable. The beaver does not know chemistry, but it builds chemistry into every dam it builds, every pond it fills, every soft, dark, oxygen-poor bottom it creates. Beaver activity leaves traces in the landscape that persist for thousands of years. One of the most intriguing aspects of studying beavers over long timescales is the way their activity leaves marks in the earth that outlast the animals themselves by millennia. When a beaver pond eventually drains, either because the beavers abandon it or because the dam fails after the colony moves on, or because the food supply in the surrounding forest becomes exhausted, the pond becomes a meadow. What is left behind is a flat, bowl-shaped depression filled with the rich, dark, organic-laden sediment that accumulated over decades or centuries of pond history. These beaver meadows are among the most fertile small ecosystems in the temperate world. Grasses and sedges grow in them with extraordinary density. Wildflowers colonize their edges. The soil is soft and deep and dark, nothing like the thinner, stonier soil of the surrounding uplands. Pollen cores taken from beaver meadow sediments can reveal the entire history of the forest and climate surrounding the site, layer by layer, year by year, back through thousands of years. In such cores, researchers can sometimes identify the specific layers of pond sediment, rich in organic matter and characteristic of still water, and trace them back to the period when beavers were present at the site. The absence of beavers is visible in the cores too, in the changing character of the sediment. After the pond drained, the earth remembers the beaver, in the chemistry of its soil, in the shape of its valleys, in the flatness of its meadows, in the pollen trapped in its sediment that tells the story of what grew here, century after century, while the dam held and the pond filled, and the beaver family slept in their lodge through the winter. Beavers and indigenous peoples of North America shared thousands of years of history together. Long before the European fur trade transformed the relationship between humans and beavers into one of commercial extraction, indigenous peoples across North America had developed rich and varied relationships with the beaver over thousands of years. For many nations, the beaver was a source of food, its meat nutritious and available through the winter. Its fur was used for clothing and trade. Its castor glands and other parts were used medicinally. But the relationship was not purely practical. In the cosmologies of many nations, the beaver held a special place. Among the Ojibwe and Cree and many other Algonquian-speaking peoples, the beaver was associated with industry and foresight and the capacity for careful preparation. Stories told of the beaver as a teacher, demonstrating through its behavior the virtues of hard work, preparation, and living well within one's place in the world. In many traditions, beaver were hunted with careful attention to sustainability, with protocols that ensured populations were not overexploited. Particular ponds were managed for continued beaver presence. The bones of beavers taken for food were sometimes returned to the water, in practices that combined practical game management with deep cultural meaning. These traditions encoded knowledge about beaver ecology, knowledge that European scientists would take centuries to formally discover and express in the language of ecology rather than story. The disruption of these relationships by the commercial fur trade was therefore not merely an ecological crisis, but a cultural one. The near extinction of the beaver diminished not only the wetlands and waterways of the continent, but the living traditions of peoples, whose understanding of the world was shaped by generations of careful observation and coexistence with this extraordinary animal. The recovery of the beaver is therefore also, in some small way, the recovery of a relationship. Watching beavers has become a form of slow tourism in many parts of the world. In the places where beavers have returned, a quiet industry has grown up around the simple act of watching them. In Devon and Scotland, guided beaver watches draw visitors to riverbanks in the golden hour before dusk, to stand quietly at the water's edge and wait. The waiting is part of it. The slowing of the pace to match the pace of the animal, the willingness to stand still and be patient. And then, often without warning, a dark shape appears at the surface, a V-shaped wake spreading across the still water. The beaver moving with unhurried purpose toward the bank. It pulls itself onto the mud, sits upright for a moment, nose working, checking the air, and then it begins to gnaw. And the watchers on the bank stand perfectly still and barely breathe, watching the most ordinary, extraordinary thing in the world. An animal doing the thing it is made to do, by the water it made, in the evening it owns. There is a meditative quality to beaver watching that people return to again and again. Something about the deliberateness of the beaver's movements, the unhurried quality of its work, the complete absorption of the animal in its task, induces a corresponding quality of attention in the watcher. You find yourself breathing more slowly, thinking less, simply watching. The pond and the beaver and the fading light, becoming, for a little while, enough. The beaver's immune system and disease resistance are surprisingly little studied. Despite the beaver's long history of contact with humans and the many ways it has been studied, some aspects of its biology remain relatively underexplored. Its immune function is one of them. Beavers live in water, which is a rich environment for pathogens of all kinds. The same pond that supports such wonderful biodiversity also contains bacteria and parasites and viruses. Yet beavers generally appear robust and healthy in their natural environment. One disease of note is Giardia, a parasitic protozoan that was once colloquially called beaver fever because it was thought to be spread primarily by beavers contaminating water sources with their feces. It is now understood that Giardia is spread by many animals, including humans, and beavers are no more or less responsible for its presence in waterways than other wildlife. But the name stuck, a piece of unfair reputational damage that the beaver has borne without complaint. What is known is that beavers develop some resistance to the pathogens they encounter regularly in their ponds, and that their general health appears closely tied to the quality of their environment. Beavers in degraded or polluted waterways show higher rates of disease and poorer condition than those in clean, well-functioning ecosystems. Their health and the health of the water they inhabit are, as with so many things about this animal, deeply interconnected. Beavers are among the few animals that modify the local climate around their habitat. We have spoken of how beaver ponds create cooler, moister microclimates in their immediate surroundings. But the effect is more than incidental. Evaporation from the pond surface releases water vapor into the local atmosphere, increasing humidity around the pond and in the forest beyond it. This moisture increases the chance of local rainfall and dew formation. It reduces the rate at which the surrounding soil dries out. It creates conditions in which more species of plant can survive through dry spells. In arid or semi-arid landscapes, these effects can be particularly significant. Research in the American West has shown that the riparian zones around beaver ponds remain green and productive well into summer droughts, while the surrounding landscape browns and dries. These green ribbons of vegetation along beaver-managed streams serve as refuges for insects, birds, reptiles, and small mammals during the most difficult months of the year. Some researchers have proposed that a sufficiently dense network of beaver ponds across a watershed could measurably increase local rainfall through the extra moisture they add to the atmosphere. This remains speculative, and the scale required would be vast. But it is not an impossible idea, and it adds yet another layer to the already remarkable accounting of what a beaver does for its landscape. Not just managing water on the ground, but perhaps, in some small and uncredited way, encouraging water to fall from the sky. Beavers are drawn to the sound of water in ways that shape their entire landscape strategy. We know that beavers respond to the sound of running water as a trigger for dam-building behavior. But this sensitivity runs deeper than simple stimulus and response. Beavers appear to build dams preferentially at locations in a stream where the acoustic signature of the water matches certain parameters, perhaps related to the volume of flow, the turbulence, the specific frequencies of sound that running water produces in different channel geometries. This acoustic sensitivity may explain why beaver dams so consistently appear at locations that are, from a hydraulic engineering perspective, genuinely good dam sites. The narrowing of the channel, the change in gradient, the presence of a natural lip in the streambed, All of these create particular sound signatures that the beaver's nervous system has been calibrated over millions of years of natural selection to find attractive. The beaver hears the potential of a dam site before it sees it. The water is calling to it, and it answers with mud and sticks. This is one of the things that makes studying beaver cognition so interesting. The animal is not consciously calculating hydrology. It is not planning. Yet the outcomes of its behavior are so well suited to the engineering goals it appears to be pursuing that it can be difficult, watching a beaver work, to remember that what you are observing is instinct rather than intention. The river speaks. The beaver listens. And between them, something remarkable gets built. Beavers may live for up to 24 years in the wild. The lifespan of a wild beaver is not easily observed, since tracking individual animals over many years requires considerable effort and consistent monitoring. But studies of marked or radio-collared animals have provided some data. Most wild beavers probably live between 10 and 15 years. The oldest confirmed wild beavers have approached 24 years of age, a very considerable lifespan for a medium-sized mammal. In captivity, where the threats of predation, harsh winters, and the risks of dispersal are removed, beavers can live somewhat longer. But it is in the wild, engaged in the full complexity of their natural lives, that the beaver's longevity is most meaningful. A 15-year-old wild beaver has survived perhaps 3 or 4 significant winters. It has raised multiple litters of kits. It has built and maintained hundreds of meters of dam. It has felled thousands of trees. It has packed countless handfuls of mud into the structures that define its world. Its pond, by the time it is 15 years old, is a mature ecosystem. The vegetation around it is shaped by years of the beaver's foraging preferences. The sediment at the bottom is layered with a decade and a half of accumulated organic matter. The canal system, if the site is productive and well used, reaches far into the surrounding woodland. The beaver and its pond have grown old together, each shaped by the other, each carrying the marks of their long shared history. The beaver's relationship with cold is one of biological elegance. Cold is the dominant environmental challenge of the beaver's life in much of its range. Northern winters that can last 6 months or more. Ice that forms over the pond and seals the entrance to the lodge. Temperatures that drop to extremes that would kill an unprotected mammal within hours. Yet the beaver is not merely tolerant of cold. It has built a life that is, in a sense, made possible by the cold. The frozen pond is not an obstacle. It is a roof, a protective layer that seals predators out and seals warmth in. The ice that freezes around the mud walls of the lodge makes it stronger, more solid, more impenetrable. The cold that preserves the food cache beneath the water is the same cold that keeps predators from reaching the family above the water. The beaver has turned the harshest feature of its environment into one of its greatest protections. In spring, when the ice melts and the pond opens up again, the beavers emerge with a curious combination of caution and energy. They are thin from the winter, their food cache depleted, their bodies lean. But the world is opening. The willows at the pond's edge are leafing. The aquatic plants are beginning their season's growth. And there is work to be done on the dam, which will have settled and shifted through the frost and thaw, needing inspection and repair. The beavers begin, as they always begin, without drama, without complaint, one branch at a time, one handful of mud at a time, into the lengthening days of spring, with the kits that will be born in a few weeks waiting to join the world, that is already, and always, being built for them. There is a particular quality to the light in a beaver pond at dusk. If you have never stood at the edge of a beaver pond as the sun goes down, let me try to describe it. The water, broad and still, catches the last of the sky's colors. Amber and rose, and a deepening gold that turns to orange at the western edge of the sky, and fades through lilac to a quiet, deep blue in the east. The dead trees standing in the shallows, killed by the flooding long ago, are silhouetted against this light. Their bare branches hold the colors of the sky between them, like the bones of something beautiful. Swallows are still flying, lower now, skimming the surface. A great blue heron lands at the far edge of the pond with a prehistoric deliberateness, folding its great wings like a slow thought being completed. It stands. It waits, perfectly still, absolutely patient, in the fading light. Frogs begin to call, one or two at first, then dozens, their sound filling the bowl of the pond with something that feels ancient and right. And from somewhere near the lodge, barely visible in the dimming water, a ripple begins. Small and purposeful, moving outward from a dark shape that was not there a moment ago. The beaver has come out for the evening. Its broad head moves through the surface without sound. It pauses, sniffs the air, turns, and moves toward the bank with the quiet certainty of an animal that knows exactly where it is going and exactly what it is going to do when it gets there. The light fades. The heron becomes a shadow. The stars begin to appear in the eastern sky. The beaver reaches the bank and is gone into the trees. And from the darkness of the willow thicket, a sound begins. Steady, rhythmic, unhurried. The night is beginning. The work is beginning. And the pond breathes softly around it all, holding the last of the light on its surface as the darkness comes. The beaver's scientific name carries within it the whole history of wonder and usefulness. The North American beaver is known in science as Castor canadensis. Castor, from the Latin, and before that from the Greek castor, which itself connects to the Sanskrit word kastori, meaning musk. It is a name shaped by the distinctive scent of the castor glands, carried across languages and centuries, a thread of recognition that runs from the ancient world to the present. Castor was also the name of one of the twin stars of the constellation Gemini, and one of the twin heroes of Greek mythology. The word has accumulated meaning across time, like sediment accumulates in a beaver pond. Layer upon layer of human encounter with this animal, each adding something to the name and to the understanding. Canadensis, meaning of Canada. The animal, in its very scientific designation, carries the name of a country that it helped to shape. The Eurasian beaver's name is castor fiber. Fiber from the Latin for beaver, itself possibly derived from a root related to flowing water. The same animal, 2 names, 2 continents, 2 stories. Both threads running back to the same ancient source, the oldest encounters between our species and this patient, orange-toothed, dam-building, pond-making engineer of the wetlands. Names are how we claim relationship with the world. And we have been naming the beaver for a very long time. Every part of the beaver's body is shaped by the water it lives for. We have talked about the tail and the teeth and the webbed feet and the transparent eyelid and the sealing ears and nostrils. But let us pause for a moment and consider the whole animal together as a single piece of evolutionary design. The beaver's body is dense and compact, low-slung and heavy, with the mass concentrated in the chest and hindquarters. This shape creates stability in water and provides ballast for diving. The limbs are short relative to the body, reducing drag while swimming. The head is large and rounded, hydrodynamic in its own way, pressing forward through the water without resistance. The fur is remarkable for its complexity. The underfur is extraordinarily dense, with thousands of fibers per square centimeter, each one fine as a whisper, creating a mat so tight that water cannot penetrate it. Over this, the longer guard hairs repel water further, keeping the underfur dry even in extended submersion. The beaver oils this fur from glands near its tail, working the oil through the coat with its grooming claw, maintaining the waterproofing that its life depends on. Even the beaver's internal organs reflect its aquatic life. The lungs are large, proportionally bigger than in many comparable mammals, supporting the long breath holds that underwater work requires. The heart rate drops dramatically during dives, conserving oxygen by slowing the circulatory demand. The blood is rich in hemoglobin, carrying more oxygen per unit volume than the blood of a similarly sized terrestrial mammal. The beaver is, from skin to skeleton to the very chemistry of its blood, a creature made for water. And the water is made, in return, by the beaver. The history of beaver conservation offers lessons about what we lose when a species disappears. The near extinction of the beaver and the gradual recognition of what had been lost is one of the clearest examples in ecological history of what ecologists call a shifting baseline. Each generation of scientists and land managers works with what they find around them. The landscape they inherit becomes their normal. For generations that grew up without beavers in British rivers, the degraded, channelized, ecologically impoverished rivers they knew were simply rivers. What rivers looked like, what rivers did, what rivers were supposed to be. The idea that these rivers had once been a network of ponds and wetlands and slow channels, teeming with species now rare or absent, was not part of the picture. It required historical ecology, the detective work of paleontology and old documents and pollen analysis, to reconstruct what had been there before. And with that reconstruction came the possibility of something else. The possibility of restoration, of bringing back not just an animal, but the whole system it had created, and maintained, and inhabited. The beaver is a reminder that the world we live in is not a fixed or final thing. It is a condition, one of many possible conditions, shaped by what is present and what is absent, by what we have kept, and what we have lost, and what we might still choose to return. The beaver building its dam is choosing a condition, creating it, brick by branch, from nothing but instinct and effort. And perhaps, in some quiet way, that is what we are always doing too. Let us come now, slowly and gently, toward the close of our time beside the beaver pond. The night is deep and the stars are out. The mist over the water is thicker now, soft and white, moving in barely perceptible currents across the still surface. Somewhere in the darkness, the beaver has returned to the lodge. Its night's work done, the dam holding, the pond full and quiet, the food cache safely beneath the surface, waiting for the winter that has not yet come. Inside the lodge, the family breathes together, in and out, in and out, slow and warm and unhurried. The kits are pressed close to their parents. The yearlings lie in a loose pile at one side of the chamber. The only sound is their breathing, and, very distantly, the quiet voice of the water. The ice has not yet come, but it will come, and when it does, the beavers will be ready, as they have always been ready, as they have been ready for 7 million years. The dam will hold, the lodge will stand, the food cache will feed them through the long, dark, frozen months, and in the spring, the ice will break, and the beavers will emerge into a world that needs tending, and they will begin again. This is the beaver's gift to the world. Not just the ponds and the wetlands and the clean water and the biodiversity and the carbon and the flood management. All of that is real and measurable and important. But the gift beneath all those gifts is something simpler. A demonstration, offered quietly and without drama. That patient effort is enough. That you do not need to see the whole structure to begin. That one branch placed in the right position, followed by another, and another, is how anything worth having gets built. That the best work is done not in great bursts of energy, but in the steady application of attention, night after night, season after season, for as long as the work requires. And that at the end of each night's work, it is enough to return to the warm interior of the lodge, to the breathing of those you love, to the quiet and the dark, and to rest. And so, dear listener, we leave the beaver pond now. We leave the mist on the water, and the stars above the dam, and the dark shape of the lodge at the center of it all. We leave the sound of gnawing, which has already grown too faint to hear, and the slow voice of the pond, which fades as we move further away. We have learned, tonight, that beavers are far older than we imagined, that their engineering is more sophisticated, that their family life is richer, that their impact on the world is deeper and wider and more lasting than we had perhaps considered. We have learned that they nearly vanished from the earth, and that many rivers of the world are the poorer for their long absence, and that slowly, in the places where they are returning, the land is becoming itself again. We have learned that there is something worth contemplating in the way a beaver works, in the patience of it, in the sufficiency of small, repeated efforts, in the wisdom of building well against the cold, and then resting, in the rightness of sleeping, when the night's work is done, in a warm and sheltered place, with the ones you love. Now, Let your body become heavy. Let your breath find its own slow rhythm. Let the last images of the pond fade gently behind your closed eyes. The mist, the stars, the dark water, the warm interior of the lodge, the breathing of the family inside. You are warm. You are safe. The work is done for tonight. The dam is holding. The pond is still. The stars are keeping their quiet watch overhead. And somewhere in the dark, beside a pond that did not exist until something patient made it, a family of beavers is sleeping. As you can sleep now too. Gently, slowly, without urgency. One breath at a time. Good night. And thank you for spending this quiet time at Sleepy Science. If you are still awake, a new journey waits whenever you are ready. But if your eyes are heavy now, let them close. Let the pond hold you. Let the dark water carry you. Let the slow, steady breathing of the beaver's family carry you gently, all the way, down, into sleep.